Good evening to all the televiewers of DepED Hour Tele-Turuan. I'm Ronaldine Lugmao from Mayapip National High School, your teacher presenter for tonight's episode. For tonight, we will tackle the parts and functions of the multitester. This is from electrical installation and maintenance under technology and livelihood education subject. Let us first define what is the multitester. The multitester, or a multimeter, also called the BOM, voltmeter, ohmmeter, and millimeter, an electronic measuring instrument that combines several measurement functions in one unit. A typical multitester can measure voltage, current, and resistance. It is generally made of two types, the analog multimeter and the digital multimeter. The digital multimeters, or DMM, is a tool used to measure two or more electrical values. The DMM have a numeric display and may also have a graphical bar representing the measured value. And an analog multitester is a measuring instrument used to measure electrical quantities. Basic functionality includes measurement of potentials in volts, resistance in ohms, and current in amps. It has a moving pointer to display the reading. Both types of multitester can be a handheld device, useful for basic fault findings and field services work, or a bench instrument which can measure to a very high degree of accuracy. They can be used to troubleshoot electrical problems in a wide array of industrial and household devices, such as electronic equipment, motor controls, domestic appliances, power supplies, and wiring systems. Let us now identify the parts of the multitester. First, we have the pointer, the needle-shaped rod that moves over the scale of a meter. It is mechanically connected to the moving coil. It indicates the measured value on the multitester scale. Another is the adjustment screw. This makes possible to adjust the pointer to the zero position of the scale. Range selector knob, or sometimes called the selector switch. This makes possible to select different functions and range of the meter. Scale is a series of markings used for reading the value of quantity. Another is the test probe. Positive, which is the red color probe. Negative is the black one. This used to connect the circuit to the electrical components being tested. And the 0 ohm adjusting knob is used to zero in the pointer before measuring resistance. Electrical measuring tools and instruments are sensitive and delicate, so extra care is necessary in handling them. Here are the proper care and maintenance of the multitester. 1. Read manual of instructions on how to operate the multitester. Number 2. In reading the amount of voltage, always start with the highest range to avoid reading voltage higher than the tester setting. 3. Be sure that the tester is set to the correct range setting. Resistance range when measuring the ohms, voltage range when measuring the voltage, and ammeter range when measuring the value of electric current. 4. Always check the condition of its battery. Worn-out batteries will damage the internal setting of the tester. 5. When the tester is not in use or will be stored, set the selector switch to 1000 volts or to off position. And last, never drop the tester. To read the multitester, let's watch the video by David Robinson.
Hello. Today we're going to discuss how to read an analog meter. My name is David Robinson. I'm an associate professor here at Los Angeles Trade Technical College. Today we live in a digital age, and people always wonder, why do I need to read an analog meter when I can have a digital meter? Well, there are some things that an analog meter can do that a digital meter can't, and we'll demonstrate that as we go through the lesson. First thing with our meter is we got to plug in our test leads. Your red test lead goes into the positive jack, and your black test lead goes into your negative jack. We're going to discuss how to read this scale. We're going to talk about how to read an ohmic value, how to read AC volts, and DC volts. So let's first talk about the dials on the meter itself. This is what we call the selector switch. I can select DC positive, DC negative, or AC. Well, you may ask, how come there isn't an AC positive or negative? Well, that's because AC is alternating current and DC is not. Why do we have a DC positive and negative? Well, we set up our meter to read a DC value with DC positive. But let's say your leads are tucked down low where you can't get to them easily enough, and you realize that your polarity is wrong. To change that, you just go to DC negative, and it switches the polarity without you having to change the leads. Now let's talk about reading the ohmic value. If you look at the scale here, the very top scale is your ohms. 0 ohms here, which means there's no resistance. And when you come over to here, to infinity ohms, which would be, for example, when I have the test leads open. The first thing we have to do, though, before we can read an ohmic value, we will set our meter on DC. Negative or positive, it doesn't matter for this situation. Then we'll take our range switch, bring it over to the highest range, R times 10,000, R being resistance, and then we'd put our test leads together. Now the needle is going to fluctuate somewhere in here. What we want to do is we want to zero this out. So we have our 0 ohm dial here, and you want to bring it down until it zeroes right to there. And that way you've zeroed out your meter. Why do I have to zero out a meter? Well, if I want to get an accurate resistance reading, I have to calibrate it. The reason I have to calibrate the meter is because there's a battery in there. And as the battery weakens, it's going to change the values that it reads. So now once we've got our meter zeroed out, we can pick a range scale to go on depending on what we think that ohmic value is. We have R times 1. So if I came up to here and I'm on the 10, that would be 10 ohms when I'm on R times 1. If I was R times 100, that would be 1,000 ohms. And if I was R times 10,000, that would be 100,000 ohms. So this is how you read it from right to left on the top. When you want to read a voltage, if you don't know the voltage, always select the highest scale. But if you know your voltage, select the appropriate scale. For example, let's say I was going to work on 120 volts. I would select the 250 volt scale, put it on my AC, because that's what we're going to read first. And that is this scale right here, the red one that's reading this way. And the numbers up here is the 250 volt scale. So if I came across to, let's say, this point right here, I'm on the 250 volt scale, so that's 125 volts. If I was on the 50 volt scale, I'd be reading this here, that'd be 25 volts. And if I was on the 10 volt scale, I would be reading down here, that would be 5 volts. So 5 volts total. So that's how you read the AC scale here. You'll notice that the DC scale is slightly off from the AC scale. So you don't want to read up here. You want to read on the red scale for AC.
Okay, now you know how to read the multitester. Did you find it interesting to do? Yes? Okay, and also very useful, right? Now, Tele-Turuan will be right back after this short break.